A very good morning, 11th standard students. Continuation of a fifth chapter. I think when I say fifth chapter, I believe that you will immediately think of its name. What is the name of fifth chapter? Yes, binomial theorem, sequences and series. So far 30 problems we have completed. All those 30 sums are based on few concepts. First few problems are based upon binomial theorem. In binomial theorem, first we started with the formula of binomial theorem, that is x plus a whole power n. There we started the chapter. From that basic formula only, all the algebraic formulas that you have studied in your lower classes came from, including a plus b whole square, a minus b whole square, a plus b whole cube. So all those formulas are derived only from the binomial theorem. So it is the base for all the algebraic formulas. And we discussed about the properties of the terms present in the right hand side of the formulas also, and related properties of binomial theorem, that is x plus a whole power n means what is x minus a whole power n. If the power is rational number, what is the formula and all we have studied. After that we started sequences and series. We have seen 4 types. Even in the previous class I told you 4 types. What are they? Arithmetic progression, geometric progression, harmonic progression, arithmetico-geometric progression. In this class we are continuing with our problems related with series. Question number 31. Expand in ascending powers of x and find the condition on x for which the binomial expansion is valid, and the term given is 1 by 5 plus x. 1 by 5 plus x was the term given to us. Now if we see if you see the question, expand in ascending powers of x, you know ascending order means from lower to higher. So expand that in ascending powers of x and find the condition on which this binomial expansion that we are going to expand this, no, that expansion is valid for what? That is the second question. What is the condition for expanding this? So how to start with means first this term is taken, and from these two 5 is taken as common. 5 is taken as common. So what happens? 5 will become 1 and x becomes x by 5, right? By taking 5 common from these two terms. Now this becomes 1 by 5 that I have written here. This term, it is power 1 here. When it goes to the numerator, it becomes power minus 1, right? Suppose instead of taking 5 as common here, if I take x as common, what will happen? Can you guess? If I take x as common, what will happen? 1 plus, yes, 1 plus 5 by x, like that it will come. What is common thing that we have taken? 5. 5 is taken as common, so 1 plus x by 5, like that it comes. Bringing this denominator to numerator, it will become power minus 1. Now if we see this is clearly in a formula. Can you guess what is the formula? I'll write the formula here. 1 plus x whole to the power of minus 1. So this is the formula, right? What is the answer for this formula? 1 minus x. Yes or no? Can you guess what formula I am applying? 1 plus x whole power minus 1. 1 minus x plus what? X square, right? Yes or no? Yes, but the formula that I am going to write is 1 plus x whole power minus n. Can you remember the formula for this? I told you if it is plus and minus here, then we will have alternate symbols. So 1 minus, since it is n here, we are writing the general formula now. 1 minus nx plus, since power is negative, we will be having positive terms here, n plus 1 by 2 factorial x square. So if you see, first term is plus, second term is minus, third term is plus, so fourth term will be minus, etc. So this is the formula that we know, 1 plus x whole power minus n. The formula is this. But if you see here, in place of x we are having x by 5, in place of n we are having 1, right? So we have to substitute in this formula. So 1 minus n place means 1, I have to write, x place x by 5, so 1 minus x by 5. Next symbol is plus, so plus into n plus 1. N is 1, so 1 into 1 plus 1 is 2 by 2 factorial x square minus, it goes on like that. So when we take 5 inside, what happens? 1 by 5 into 1, 1 by 5. 1 by 5 into minus x by 5, minus x by 5 square. If you simplify, this 2 and 2 will get cancelled, because 2 factorial means 1 into 2. So definitely these two will get cancelled. If you bring 5 inside, it becomes x square by, already 5 square is here. If you combine this, it becomes 5 power 3 minus, etc. So they have asked us to expand this term, and we have expanded it like this in ascending powers of x, x power 0, x power 1, x power 2, like that we have written. The second question is, find the condition on x for which the expansion is valid. Now the expression, we already, when we studied all these formulas, we insisted on one condition particularly, that is this: modulus x should be less than 1. That is the condition that this term should follow, then only we can apply this formula, I said. If we look at that condition, when we apply that condition here, what is x value here? X by 5. So modulus of x by 5, in place of x we are having x by 5. So modulus of x by 5 should be lesser than 1. If this is the case, then only we can do like this. Keep in your mind, when we can do like this, only when this x by 5, that value should be lesser than 1. If we take modulus, the value should be lesser than 1. What is the meaning implies? Just cross multiply this 5. So modulus x should be lesser than 5. This is the condition that should satisfy when we want to expand this. If we expand this, which means this condition should be there. That is what is the second question. Find the condition. This is the condition. So you will understand this when you studied the formula which was given to you in the previous class. All those things are main formulas. I said immediately learn that. Even if you haven't completed learning, just complete that and come to this video. So this is the formula that we have already studied. Using that, we are expanding this and writing the condition here. Question number 32. Expand 5 plus x square power 2 by 3 and find the condition for which the expression is valid. Almost a similar kind of problem which as 31st sum. 5 plus x square power 2 by 3. Find the condition for which the expression is valid. So first we are writing this question, 5 plus x square power 2 by 3. From these two, taking the number as common, 5 as common. Even if we take 5, it will come with the power. So 5 power 2 by 3 is taken outside. If I take 5 outside, what will happen? This becomes 1. This becomes x square by 5. That is what is written here, and power 2 by 3. We have taken 5, but it comes out with the power. So this step comes, right? Now 5 power 2 by 3 into, what is the formula here? Can you guess? 1 plus x. I'll write the formula here. 1 plus x whole power n. Plus and plus. So all the terms will be plus here. So formula is 1 plus nx plus, since the power is positive, we will have negative symbol present here. n minus 1 by 2 factorial x square plus, it keeps on going like this. So this is the formula. This we have already studied in our previous class. So applying this formula here, 5 power 2 by 3 as it is, 1 plus x whole power n. So 1 plus nx plus n into n minus 1 by 2 factorial. What is n here? 2 by 3. What is x? X square by 5. So you should keep that in your mind. In x place we are having x square by 5. In place of n we are having 2 by 3. So 1 plus nx plus n into n minus 1 by 2 factorial x square plus it goes on like that. So 5 power 2 by 3, 1 plus, this is easy, 2x square by 15. Now you try to understand this. I will explain this. What is this? 2 by 3. If you simplify this, what happens? Shall I write here? This value, I am writing it here, 2 by 3. If I simplify this, what happens? 2 minus 3 minus 1 by 3. So into minus 1 by 3. 2 factorial means 2. That is also present in the denominator. So into 1 by 2. If I expand this, it will become x power 4 by 5 power 2, 25. Square and square. This becomes x power 4. This becomes 5 square. So 2 and 2 gets cancelled. 3 into 3, 9. 9 into 25 is 225. If you see the numerator, minus, only minus present. So minus x power 4. So that is how it comes. So we have expanded this like this. The second question is find the condition for which the expression is valid. So when this expression is valid, only when this x value, that is in place of x square by 5 is present, that modulus should be lesser than 1. By cross multiplying we can say modulus x square should be lesser than 5 is the condition for expanding this expression. So 31 and 32 almost same type. Question number 33. Prove that cube root of x cube plus 6 minus cube root of x cube plus 3 is approximately equal to 1 by x square when x is sufficiently large. So you should note this approximately equal, not exactly, but approximately equal to this value. Which one? When we simplify this one. What is this? How to read this? Cube root of x cube plus 6. Cube root of x cube plus 3. When we subtract this, then the answer is approximately equal to 1 by x square. That is what we need to prove. The condition, important condition given is when x is sufficiently large. When x is bigger, when x is very bigger, you prove this result. That is the question. We will see the answer now. Now see, since x is large, 1 by x definitely will be lesser than 1. This is the important condition that we should know. So if x is large, for example, if x is equal to, suppose I am taking 1 lakh for example, very large, even I have not taken very large, just I have taken 1 lakh. If x is equal to 1 lakh, what happens for 1 by x, which is 1 by 1 lakh, right? The value is definitely, it will be very less, because numerator, when the denominator becomes more and more, definitely the value will be very less. Definitely this is lesser than 1. Actually, if you want the answer is what? 0.00001, like that it will come, right? So definitely if x is sufficiently large, 1 by x value will be definitely lesser than 1. That is what we are writing here. Since x is large, modulus of 1 by x will be lesser than 1. Now actually this is the question given to us. Cube root means we can write in powers as 1 by 3. Similarly, x cube plus 3, cube root is written as power 1 by 3. In the next step, from these two, taking x cube as common, from these two, take x cube as common, so that it becomes 1, 6 becomes 6 by x cube, and power 1 by 3 I have written for both the things. Usually when I take x cube as common, it will come with power, but I have not disturbed the power here. It is also 1 by 3, this is also 1 by 3, I have put the whole bracket here, right? From this inside I am taking x cube out, so this it comes like that. Same manner, take x cube outside, you will get this. Now Now apply the power. Power 1 by 3 when comes here, 3 into 1 by 3. So x cube power 1 by 3. 3 will get cancelled, it becomes x. So anyhow the power will come to x cube. So x cube power 1 by 3. Answer is 3 will get cancelled, x. Similarly this power 1 by 3. Same way minus 1 by 3 goes to here, becomes x. And then for this you put 1 by 3. Now I have to apply the formula of 1 plus x whole power n. Here also 1 plus x whole power n. For applying this, this should be lesser than 1, right? Definitely since 1 by x is lesser than 1, 6 by x cube will also be definitely lesser than 1, right? 1 by x itself is lesser than 1. Definitely 1 by x cube is going to be lesser than 1 only. Keep that in your mind. So I can apply the formula. Which formula? 1 plus x whole power n formula. Since plus and plus every terms are positive, so 1 plus nx plus, since the power is positive, n into n minus 1 by 2 factorial x square plus etc. This is the formula. According to that formula we are applying this. 1 plus, this is n because n is 1 by 3, x is 6 by x cube plus etc. minus x into same formula 1 plus x whole power n, 1 plus nx plus etc. Even I have not written the third term, because if I write the third term, what happens? It will become 6 by x cube whole square will come. So 6 by x power 6 will come. 1 by x itself very less. So 1 by x power 6 and all will be almost equal to 0. So we are omitting those terms. Keep that in your mind. A formula goes on like that, but we have taken only two terms because x is very large. 1 by x will be lesser than 1. 1 by x itself is lesser than 1 means 1 by x cube itself will be very lesser value. If I go for the next term, x power 6 will come. 1 by x power 6 will be almost equal to 0. So we need not take those terms because of x is very large. Understand this reason perfectly. So that is why we have not written the next term. Here also we have stopped on only two terms. If you go for the next term, x power 6 will come, right? Because x square means this whole square. If I square this, x power 6 will come. It will be very, very lesser value. So we are omitting that. So bringing this x inside, you will get this. Bringing this x inside, you will get this. Because x gets cancelled. 3 gets cancelled. You will get this. Then you subtract this x minus x. So x minus x will get cancelled. 2 by x square minus 1 by x square. So there are so many terms we have not written. So I just put dot dot dot. So if we simplify this, 1 by x square approximately, because the other terms are all almost will be equal to 0 only. So slight variation only will be there with this answer, but still we are writing approximately. So when we subtract this, the answer is 1 by x square. But the answer is approximate answer because we have left so many terms, but all those terms only will give very, very small value, right? So we can write approximately this is equal to 1 by x square. This is an important sum, so try to understand this sum properly, even write and practice. The next sum is also a similar type of a problem. Question number 34. Prove that square root of 1 minus x by 1 plus x is approximately equal to this answer when x is very small. And if you see this problem, the condition given was x is very large, sufficiently large. Here x is very small. What we need to prove? The value of this is approximately equal to 1 minus x plus x square by 2. This is what we need to prove. So we'll go for the answer now. Now just see, this is the question actually, right? This is the question. 1 minus x root means we can write the power as 1 by 2. Here also root is there, so power 1 by 2. I think no doubt here. So numerator, just take the denominator to numerator so that the power becomes minus 1 by 2. So that the power becomes minus 1 by 2. Now for this, applying the formula, what is the formula? Formula I am going to write in the rough column. 1 minus x whole power n. 1 minus x whole power n. What is the formula? Alternative symbols 1 minus nx plus n into, since the power is positive, n minus 1 by 2 factorial x square minus etc. It will go like that. When you see formula for this, it will come as 1 plus x whole power minus n. 1 plus x whole power minus n. Now plus and minus, so again alternative symbols 1 minus nx plus, but since the power is negative, I should write n plus 1 by 2 factorial into x square minus etc. So try to understand these two formulas clearly. Here the power is positive, so we are writing n minus 1. Since power is negative, we should write n plus 1. So according to that, 1 minus nx plus n minus 1 by 2 fact. Why I am putting minus? Because power is positive. X square minus etc. For this bracket, we have written the formula here. 1 minus n is 1 by 2 x plus n into n plus 1. Why I am writing n plus 1? Because the power is negative. So n plus 1 by 2 factorial x square minus etc. Now if we simplify this, that is, this is 1 minus x by 2. Just understand this simplification. I'll write this here. See, 1 by 2 first is 1 by 2 is present. If we simplify this, that is, if you take this here, 1 minus 2, which is minus 1 by 2. 2 factorial means 2, which is present in the denominator. So into 1 by 2 x square. What is the answer now? 2, 2, 2. So minus 2, 2, 2. Minus 1 by 8 x square. So minus x square by 8. By simplifying this, you will get this. Same way, second bracket, for this you simplify, you will get plus 3 by 8 x square. Now I am going to multiply these two brackets. Keep in your mind that x is very small. For this problem, it is given, the condition was given to us. The condition is x value is very small. So when I multiply 1 with 1, the answer is 1. 1 into minus x by 2, minus x by 2. 1 into 3 by 8 x square, 3 by 8 x square, right? See, even if you see here, 1, 2, 3 terms I have written. The next term I have not written because x is very small. So x square will be very, very small, right? X is very small. Therefore, if I square that, the answer will still become very smaller. If I go for x cube, almost the value will become 0. So we are omitting the terms of x cube and higher powers. X cube, x power 4 and all will be giving almost answer close to 0. So that we are not writing the fourth term and all. In the same way, 1 is multiplied with all the terms I have written here. When x by 2 and 1 is multiplied, that is minus x by 2 into 1 minus x by 2. Minus x by 2 into minus x by 2 becomes plus x square by 4. But when I take this to the third term, what happens? X into x square becomes x cube. Since x is very small, we are going to omit x cube term. So even though the term is coming as x cube, I am not going to write that because it will be almost equal to 0. So 1, I am getting 3 terms. With this minus x by 2, when I multiply, only I am getting 2 terms. Here x cube comes, so I am omitting that. Similarly, take this to this. The answer is minus x square by 8. When I take this to the second term, it becomes x cube. So I am not interested in writing that. X square into x square, x power 4. X cube itself I omitted. So definitely I will omit x power 4. So only this I will be writing. So simplifying this, 1 minus x by 2 becomes minus 2x by 2. That is, I am combining this and this. Similarly, when you combine this term with this, it becomes 3 minus 1, 2x square by 8 and then plus x square by 4. Simplifying, you will get, if I cancel this 2, it will become 1 minus x, 2 with 4. So LCM, if you see, same. So x square plus x square is 2x square by 4. Cancelling this, we are getting x square by 2. So this is what we need to prove, 1 minus x plus x square by 2 approximately. So this is the approximate answer. These are all important sums, write and practice. Going to the next sum. Question number 35. Find cube root of 1001 approximately to 2 decimal places. So they are asking us to find the value for this in 2 decimal places. So writing this as power 1 by 3, splitting 1001 as 1000 plus 1. From these two, take 1000 as common. So what happens? 1 plus 1 by 1000 power 1 by 3. So if I bring the power to 1000, 1000 power 1 by 3 will become 10, right? 1000 power 1 by 3. The meaning is what? Cube root of 1000, which means 1000 can be written as 10 into 10 into 10. Since this root is cube root, 310 means we can take 110 as outside the root. So cube root of 1000, cube root of 1000 is 10, and for this power is 1 by 3. Our formula is 1 plus x whole power n. Definitely this x value should be lesser than 1. The modulus is lesser than 1. Definitely if you see 1 by 1000, the value will be lesser than 1. So we can apply the formula. 1 plus x whole power n. What is the formula? 1 plus nx. Just we are writing two terms plus etc. 10. 1 plus, this is 1 by 3000. 1 by 3000 means 0.000333. I think you will know this. When we add these two, 1.000333, multiplying these two, the decimal will go one place to the right side, right? So answer is 10.0033. So since they asked two decimals, since all the two is 0, we are writing one more term. Even you can stop the answer here, or even you can stop here itself. Next problem. Question number 36. Write the first 6 terms of the exponential series e to the power of 5x. For these type of problems, only the formula can help us. Write the first 6 terms of the exponential series e power 5x. So we should know what is the formula for e power x, what is the exponential series expansion. That is, e power x can be written as 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial, and it goes on like that. So just in place of x we are having 5x. Use that same formula and replace wherever x is there, you just replace it by 5x. What happens then? 1 plus, in place of x I have written 5x by 1 factorial, 5x whole square by 2 factorial, 5x whole cube by 3 factorial. Like that I am writing 6 terms and then simplify it, that's all. 1 factorial means 1, so you can write 5x. 2 factorial means 2, if you expand this 25x square. 5 cube 125x cube, 3 factorial is 6. This is 625x power 4, 4 factorial value 24. In the same way expand this. Since they have asked 6 terms, you just find 6 terms and put dot dot dot. Going to the next term. Write the first 4 terms of the logarithmic series expansion. So a logarithmic term was given and we are asked to expand it. Log 1 plus 4x. First 4 terms they are asking. So again what? As in the case of exponential series, we should know the formula for logarithmic series expansion. Log 1 plus x can be expanded as x minus x square by 2 plus x cube by 3 minus x power by 4 plus etc. Alternative symbols. Just listen carefully. Denominator does not have factorial, just numbers 2, 3, 4, that's all. If you see that there are factorials, 1 factorial, 2 factorial, 3 factorial, here just numbers. But in place of x we are having 4x. So log 1 plus 4x means in place of x you write 4x, x means 4x, like that. So 4 terms I have written, then dot dot dot. This becomes 4x. This is 16x square by 2 plus 64x cube by 3, right? 4 into 4 into 4. Similarly 4 power 4, 256 x power 4 by 4. These 3, this can be cancelled, this can be cancelled, so cancelling and writing the final answer. So this is the expansion of log 1 plus 4x. Hope you will understand. We will go for the 38th problem that will be continued in the next video, right? So don't think the class gets over here. We are having one more video continuing with problem number 38.